All right, a little project update. We are done, just about done with all of the RF stuff on this radio. All the resistors, pretty much all the dog bones were high, and they were significantly high. We're talking like 15, 16%, some were more than 20% high, so they had to go. I have a rule, and I know they were originally 20% was the tolerance, but I don't care. If it's 10% high or more, it goes. So those most of those dog bones are out of there. You can see I kind of working my way through the radio, one component at a time, guys, one component at a time. Don't do more than that. And I'll clean up all that flux left over from the factory days later. I did a little bit of corkscrew, but mostly cleaned up the terminals and resoldered brand new to the terminals. It just depended on the situation. And now I'm going to get into the power supply. And this power supply has been worked on and hacked on. So I've got a lot to do there. I left it for last because I needed to kind of get my bearings in this radio. And you got these I think old Radio TV Phono Nut calls these black bombs. So I got some black bombs in there. I got some bizarre non-original capacitors. And then there's this one IRC deal way down there. You see that thing? Looks like a giant dog bone. I have no idea what that thing is or what I'm going to do with it. I'm not really familiar with that style of component. Maybe all of you out there are, but I'm not. So I'm going to have to dive into that. I'll probably hit that tomorrow. And it'll show up on the same video as this video right now. Once I get all that stuff replaced, and that includes I'll put a couple terminal strips in there and put the electrolytics nice and firm rather than dangling them from that phone wire. Once I get all that done, well then I'll come way over here and I'll start hitting the grommets for the tuning condenser, and I'll get that tuning condenser squared away. If you look at the 6F6, the output tube of this radio, you see that the cathode, which is pin number 8, is supposed to be grounded. Let me show you what's in the radio. It's connected through a capacitor to ground, and then there is also that weird IRC resistor. It looks like it goes to ground. And then this red wire here, it goes off to the negative side, the ground side of this pair of capacitors here. None of this is supposed to be there. So I'm going to pluck all of it out and set this thing up according to the schematic. All these capacitors, all this mess, and this red wire with that resistor, all of it was connected to pin 8 down there of the 6F6. I'm cleaning all that out of there because none of this belongs. I have no idea why this was all there. Plus that big 20 microfarad electrolytic was there. And these two electrolytics here, none of these belong here. So I've got to get it all out of there. It's a mess. Well, I finally got around to tinning my big soldering gun. Look at the size of that beast. Kind of looks like a Battlestar Galactica coming into frame in the movie, doesn't it? Look at that. Alright, so I'm going to take this big soldering gun and I'm going to show you why I bought it. I want to remove the solder from this big ground lug here. But if I use my ordinary Weller soldering iron, it loses heat so fast into the metal of the chassis that I can't get it hot enough. So let me turn this thing on and see if I can get this thing to do it. Now this thing is, when I have it on high, it's at 500 watts, where my normal soldering iron is at 140 watts. So this takes a little while to heat because there's a lot of mass here, but it does a pretty good job. But the only complaint I have is that the spring is really strong on the trigger, so your hand gets a little tired if you have to hold it for a minute. There we go. Alright, so we're putting some heat to it. Oh yeah, it's getting it all. Wow, some of it just dropped through the hole. So let's soak this puppy up. Oh yeah, this thing puts out some heat, man. Yikes. Only I have to learn how to work with it. I'm a little clumsy. Normally I would be fighting this because I'd be losing all the heat into the chassis. Okay, my aim is not to remove that ground. I just wanted to clean that up so I could attach some other wires to it and then resolder it. There's no excuse for leaving that mess on. When I solder the new wires on, I'll put some new flux on, but I'll clean that up when I'm done too. In case you're wondering, I'm using lacquer thinner to do this. Lacquer thinner is like my favorite all-purpose cleaner. Not quite sure why there's so many wires wrapped, so many turns wrapped around this lug. It's just not required. See, look at that. That's kind of a waste. Guys, don't do this. Don't wrap things around 4 or 5 times. It just makes for difficulty working on things later. It's not required. Requires a lot more solder to get a good solder joint. It's just, there's no point. It does not, I repeat, it does not improve your electrical connection. All it does is make a mess. What I did here also is I removed this 0.02 microfarad 800 volt capacitor that went from the 4th pin of the 6F5 to the 5th pin of the 6F6. And I'll show you that in the schematic. There we go. 0.01 800 volts. C15. There is C15, 0.01 at 800 volts. I noticed something on this schematic and it threw me off for a while, that none of the decimal points are visible. So for some of them it was actually tough to tell until I got into the circuit and started to analyze it a bit. Like this right here. That is actually a 0.25 at 200 volts. This can dome had tested fine earlier, but when I retested it again as I began working on this section of the radio, it tested open. So now I kind of have to replace this thing with something else. I'll do what I usually do. I'll just install a terminal strip and use individual resistors. Okay, so here's what I'm going to do about that can dome problem. I've already started it, and I disconnected everything from the terminals of the can dome. I'll bring this resistor here to this terminal, and then this terminal here is supposed to be grounded. What I'm going to do is I'm going to solder this. I've already mounted this terminal strip, but I want a good solid ground here. So what I'm going to do is solder this ground to the chassis. And see if I can't press it as tightly as I can against the metal. I've already sanded the metal. I'm going to use an abundance of solder flux. Okay, I've got some fresh solder flux. Thank gosh, I was getting tired of messing with that dried old sticky solder flux. So I'll put an abundance of it on there. I know it looks like I'm going crazy, but I need it to flow really nice. So that's why I'm doing that. I'm going to put a big old blob of solder there. So let's heat the gun up. We'll know when it's hot in just a minute, when it starts to melt on there. Gun takes a little bit of time to heat up, but there's a lot of mass to heat too. Kind of wish it heated up faster than that, but it holds a lot of heat. Okay, so now I'm going to heat the living daylights out of this down here. Get this chassis good and hot. I don't know if you can see or not. Alright, once that solder gets good and melted, then once it gets where it's nice and liquid, then you put lots of it on there, and you want a nice big blob. You get it good and hot. Once you get it good and hot, you'll get a nice puddle of solder, and you hold that terminal strip steady while you lift the soldering iron out of there. Then it's going to take a second to cool. Alright, let me clean and tin my soldering iron. And I think we got ourselves a good ground connection there. And I'll go ahead and finish connecting up the rest of this, what used to be the can dome, and I'll make that work instead. This ridiculous looking thing belongs to the Naughty Brothers, Fred and Buster. If those of you that don't know my videos, let me tell you that Fred and Buster are my two cats. Well, they, you know how little kids have a favorite teddy bear, favorite toy that they treasure? Well, the Naughty Brothers treasure this stupid thing. This is their little scratching deal. And they've somehow managed to split it in half. Now, believe it or not, at China Mart, these things cost about $15. And I don't see the point in going to spend another 15 bucks on something like this just because it's made like crap. So, what am I doing? Well, just to show you that you don't own cats. You're not a cat's buddy. What you are to a cat is staff, okay? You are the help. And I'm doing what the help does, and I'm fixing something that they broke. So I'm going to see if this works. If it works, great. If it doesn't work, I'm not out very much. So let's just see. I know from working in manufacturing that hot glue needs a dwell time. So I'll give it a dwell time. And it's usually longer than you think. And but it should work pretty well on this this corrugated. Hot glue likes to get into all the little ins and outs, and then once it hardens, it glues pretty well. Now Fred gets pretty distraught when I take this thing away from him, so I better hurry up and get this done so that he can have his toy back. And what they do is they fight over the right to lay on this. This is sort of like a hill in the Korean War, you see. They fight for this hill. So let's see what we can do. Lots and lots of glue. It's not going to hurt a thing. I think this glue's even non-toxic. Put a bunch of it in here. We'll probably use this whole stick. This paper is a good insulator, so it takes a while for this glue to harden. And this gun is getting tired. I used to work in cheese manufacturing, and if you ever got hot cheese on your skin, it was a real problem because not only was it hot, it had a lot of heat built up into it that it would start unloading into your skin, but the stuff stuck to you, kind of like napalm, and you couldn't get it to let go, and so it would burn for a long time. Now, this thing's about had it, but what the heck, I'll give them a couple more weeks with it, and then we're going to have to probably replace that silly thing. But the cats love this thing, so might as well. Alright guys, there we go. Good as, well, almost as good as new. Good as a garage sale new. I'll put this aside and let that glue harden all the way, and the cats might get another few days out of this thing. See this resistor? It's a 1 watt resistor. And those of you who know the color code, this is a 270 ohm resistor. But you see the silver band there, that tells me that it's a 10% resistor, not a 5% resistor. So this thing will be within 10% of 270 ohms. Now let me show you something. That resistor R16, which was the can dome, that can dome, when I originally tested this radio, had measured 289, but somehow it measures open now. It might have been when I was removing a component, it got hot and went open, don't know. Things separate on those can domes and things like that happen. It's supposed to be 280 ohms. What I have here with this 10% resistor is 276.1 ohms. That's perfect. If this had been a 5% resistor, I might not be able to make this 270 ohm work, because it more than likely would have been a lot closer to 270 versus 280. Now I know we're only talking about a few ohms here, And that's fine, but it doesn't hurt to get as close as you can as you're putting a radio together. That helps to eliminate things to go troubleshoot. This is why I like to when I go buy resistors, and I buy them in bulk at Ray Elko. But when I buy resistors, I always buy a whole bunch of 5% for those times when I really want it to be dead on. And then I also buy a bunch of 10% resistors and even some 20% if I can find those. And I do that so that the resistor is more than likely will be a little bit off the mark. And sometimes I can tweak like I'm doing right now. And there we have it. So I have taken this can dome out. I soldered the ground nice and firm and good electrical connection to the chassis here. Connected the transformer center tap to this ground and replaced this 280 ohm can dome, which actually measured at 289, with this 276.1 ohm resistor, which is actually a 270 ohm 10%. So, I knew it would be a little off, and it just so happened to be off in the right direction. So I'm going to get to work now finishing off the power supply. I've still got the 288 microfarad electrolytics to put in, and that's what all this crap was about. And I've got to finish up making the connections from this can dome to the power supply. After that, I'm pretty well done with the electrical components under the chassis, except for the addition of a fuse, a thermistor, a safety capacitor, and the line cord. So I got a little bit to do, but I'm getting pretty close on this bugger. Well, hey guys, I thought this was a team effort. I thought that if I made mistakes, that you guys had let me know. Hey, dummy, you're screwing up here, dummy. You want to fix that. So I was right. Everything I said about the tolerance, the 10% resistor versus the 5% resistor was all very true. Except that I was making a big mistake, and it was right there in front of you, and nobody said anything. And that I was putting a 1 watt resistor in there, and we all know that can domes get hot. That's part of why they're made the way they are, right up against the chassis. And they're typically 2 watts or more. And this happens to be, on the schematic, a 2 watt can dome. So here I was putting a 1 watt resistor in there, and I was setting myself up for failure, and you guys let me do it. I can't believe it. So here's what you tell me next time. You say, hey dummy, look, if you're going to put a resistor in there to replace the can dome, make sure it's a 2 watt. If you don't have any 2 watt, well then pick some 1 watts that you do have, that if you put them in parallel or series, they'll add up to the right resistance that you want. So I have a couple of 560 ohm 1 watt resistors. If I put those two in parallel, the total wattage that these things are able to pass or dissipate is 2 watts. And because they're in parallel, it should be right around 280 ohms. And sure enough, when I connected them together, measured them with my ohm meter, I got 282 ohms. So this is just about right. It's going to have no trouble at all dissipating 2 watts, and it's the right resistance. Next time, guys, let me know so before I put the solder in, okay? Pin 8 of the 6F5 is seen here in the radio with a resistor. It looks like a 510 ohm resistor, maybe 2 watt resistor going from pin 8 of 6F5 over to ground. Looking at the 6F5 tube, pin 8, which is the cathode, is connected directly to ground according to the schematic. That resistor is not an original resistor, so I'm going to go ahead and pluck that out of there and connect that pin 8 directly to ground. It looks to me, from all the things that were done in this power supply, that whoever did this work was trying to get rid of some hum. Instead of replacing a lot of the crap paper and wax capacitors, just threw a bunch of other oddball stuff in weird places. Not quite sure I understand it, but I bet that's what he was doing. He was trying to get rid of hum.
Other than that, I just
wow, take a look at that.
We're still got
unbelievable. Alrighty, boys and girls, let's show you where I'm at like I promised. Okay, as I mentioned earlier, I had done all of the RF stuff, replaced all these caps and resistors, pretty much replaced everything. There's an occasional mica capacitor that I'll leave alone, and I'll go back and mess with those if I need to, but I usually don't need to. But certainly all of the wax and paper are gone, and all the dog bones are gone. In this radio, strangely, some radios, all the dog bones would be pretty much fine. And then other radios like this one here, every single dog bone was high by about 20%, maybe even 30 or 40% on some of them. So I've replaced all those, replaced all the caps, put good quality Panasonic film capacitors. Occasionally for some of the larger ones I use these axial capacitors. But they're getting harder to find and getting expensive, and there's no need. They're not any better. They don't work any better in this application than these nice Panasonics. So I've installed all those, all the resistors. This dog bone here, this big power resistor was fine. It measures good. This candome measured good. As we go further down in the radio, this candome here did not measure good. It actually initially measured okay. But then after I did some work, I replaced a component on it. I measured it again and it was open. So I took it out of the circuit, put in this terminal strip like I showed you earlier, installed the resistors to basically mimic the candome. So we've got 280 ohms here and we have 22 ohms here. And so this 280 ohm section here and this 22 ohm section over here. And then connected the appropriate components to it. Here are the filter capacitors. This radio only has two 8 microfarads. I'm safe with using two 10s. Ran the wires all the way over to the speaker connector where those capacitors were originally connected and got all that junk out of here that was there before. You notice I put a ceramic disc here. These discs I've had real good luck with. These are surplus discs, but they've done a good job. If I have problems with this, well then I'll go ahead and it's a 0.01. It's supposed to be 800 volts. If I have trouble with this, and it turns out to be this disc capacitor, well then I'll go ahead and I'll get hold of Mauser and I'll order a handful of high voltage capacitors of that value. But I think I'll be okay. Same thing with these ceramics here. They add up. These are each 0.02s at 1 kV. These add up to 0.022. So this 0.0066 is what these are, and this is supposed to be a 0.006. So it's part of the tone control, the tone circuit. So I think we're okay. I did install a fuse. There's the fuse right there. Typical 3AG style fuse. Put a thermistor right here, as I always do. Connected up the line cord was connected up to this terminal strip, and they were nasty, man. It was nasty. So I took care of that. Here's a brand new power cord with the UL knot. Tone circuit here. What I have not yet done is clean each of these pots with deoxit. I'll get to that when I do the tuning condenser. Okay, so basically the underside of this chassis is all done. I don't see any real work that's left to do in here. Typically, I will leave all of my notes in the chassis. I usually ask the owner, hey, do you want me to leave them in there? And a lot of times, especially with one like this where the schematic is hard to find in the first place and then even harder to read, I leave my notes in there to help the next guy, if it's not me, that might get in this radio. The tubes are no big deal. Everybody can tell what the tubes are. But some of these things, like this resistor R4, and this is R16 over here, it's good to have that information, so I'll leave that in there. Okay, what's next? Well, we're going to clean up the tuning condenser. I'll replace the grommets and install those grommets here, and then we'll hang the tuning condenser on there again. Basically, I'll clean up the top side, get the tuning condenser on, and then I'll be ready to give it a whirl on the Variac. So we're not too far off, guys. So okay, that's where I'm at, and I'll get back to work now.